Another day, another story. An asteroid that measures up to 300 feet across could smack into Earth in 2032, and while NASA says the chances of a collision are extremely low, the probability has been increasing since the space rock was discovered weeks ago. NASA said last week that there is currently a 2.3%, or 1 in 43, chance that the asteroid, dubbed 2024 YR4, will hit Earth on December 22, 2032. While still tiny, that probability nearly doubled from the agency's initial estimate of 1.2% in late January. At that time, NASA said that no other known large asteroids have an impact probability above 1%. Welcome to Tabo Eminent Channel. The agency is monitoring the asteroid's orbit and said that the object's impact hazard could be ruled out eventually. But in a blog post about the space rock, the agency said it is also possible its impact probability will continue to rise as more details become clear. In the unlikely event that it did hit Earth, the asteroid would likely impact at a high velocity of roughly 38,000 miles per hour, according to the Center for Near-Earth Object Studies at NASA's Jet Propulsion Laboratory. A space rock of that size would likely cause local damage, but not threaten the entire planet or humanity, as might be the case if a much larger asteroid was on a collision course with Earth. The asteroid 2024 YR4 was first detected by the Asteroid Terrestrial Impact Last Alert System Station in Chile on December 27, 2024. NASA said the asteroid will continue to be visible to ground-based observatories through April. After that, the space rock will be too faint to see until around June 2028. The agency's James Webb Space Telescope will train its eyes on the asteroid in March to better assess its size, according to NASA. What is a near-Earth object? Near-Earth objects, NEOs, are asteroids or comets nudged into our neighborhood of space by the gravitational attraction of nearby planets. They are chunks of rock, metal or ice left over from the formation of the solar system some 4.6 billion years ago. Most are too small to worry about, but an impact from larger NEOs could cause considerable localized damage, such as the meteor that struck the Chelyabinsk region of Russia in 2013. It shattered windows and caused hundreds of injuries over a wide area. Destruction from the largest of these objects, such as the asteroid that likely caused the extinction of the dinosaurs about 65 million years ago, could wipe out humans. How are NEOs located? Each night, teams of astronomers in the US, Europe and Asia photograph the night sky using a worldwide network of large ground-based telescopes. The instruments used for these sky surveys are typically wide-field telescopes designed to take in a large chunk of the sky at a time, according to Larry Deno, an astronomer at the University of Hawaii's Institute for Astronomy, which runs the NASA-funded Asteroid Terrestrial Impact Last Alert System, ATLAS. We try to cover as much sky as possible, he says. We don't need to see as far as possible out in the universe. What Deno and others are looking for is an unexpected, telltale movement against the background of stars that indicates the presence of a previously unidentified NEO. Objects that are closer to Earth appear to move faster than those farther away. Imagine you pull up to a railroad track and there's a train whipping by, explains Carson Foles, director of the Catalina Sky Survey at the University of Arizona. Now imagine you see a railroad track in the distance. That doesn't appear to be moving that fast. In the same way, an asteroid that is close to the Earth will appear to be moving faster than one that is farther away, even if they are traveling at the same speed. ATLAS operates 4 telescopes. When it's dark, they are constantly taking pictures of the sky, says Deno, whose team was the first to spot 2024 YR4 from observations made on a remotely operated telescope in Chile. These are big 100-megapixel images that come back to Honolulu, and our computers reduce them and look for objects that are star-like, but moving in the exposure, he explains. With the help of computer algorithms, the astronomers can then winnow down the data. You can kind of put the good ones in one bin and the bad ones in the other bin and have, a few that are in between, to screen out false detections, Deno says. We do that for hundreds of footprints at each telescope every single night, he says. Catalina Sky Survey operates 3 telescopes. The telescope with the widest field can get a little over half of the visible sky at a time, Foles says. The real trick, when we find and track these objects, is that we're kind of looking at a 2D image, Foles says. That makes it difficult to determine the exact distance, he says. We can start to guess how far away it is once we observe its orbit. How do astronomers know how far and how big it is? Optical telescopes are the best bet for spotting NEOs, but radio telescopes are the surest way to determine distance, according to Anne Verkey, a research fellow at the University of Helsinki who has tracked asteroids using radar. And that's kind of the third dimension that's really important, she says. Radio telescopes, which use a giant dish to collect radio waves emitted from celestial objects, can also be used to bounce a radar off NEOs to determine their size, Foles says. Unfortunately, 2024 YR4 is already too far away for that. But there are other ways, he says. Observing how bright an asteroid is and how that brightness changes over time can help in determining its shape, how fast it's spinning, and what it's made of. But without knowing how reflective it is, that method is still a lot of guesswork, Foles acknowledges. Putting together a coherent picture is a bit like solving a puzzle. You'll first of all start to piece together the orbit, and then we'll say, aha, it's this, right? And we think it's at this location or at this distance, so we can get an estimate of the size from that, he says. How do scientists know if an asteroid could impact the Earth? Once an object is photographed, it gets run through a database to determine if it's already known to astronomers. That only takes about 10 minutes, Foles says. If it appears to be new, follow-up observers report it up the chain and put it on a list to re-observe in an hour or two when it's moved a bit, as a second check, he says. If it's confirmed as a new discovery, the object is reported to the Minor Planet Center run by the International Astronomical Union. From the short motion we have over a span of about 30 minutes, we can tell whether the object is likely to be close to the Earth, Deno says. But astronomers have to deal with a serious blind spot. If an object approaches the Earth with the Sun behind it, it's difficult or impossible for optical telescopes to separate the light reflected off a tiny asteroid from the intense glare of the Sun. That's how the meteor in Russia snuck up on the Earth without being noticed in 2013. The Chelyabinsk meteor came from the Sun side, Deno says. What happens if it looks like a possible hit? It depends on how large it is. If the object is big enough to be a real threat and has a 1% or greater chance of hitting Earth based on initial calculations, it is reported to the International Asteroid Warning Network, IAWN, a global collaboration started in 2013 to monitor and track space objects that could impact Earth. For 2024 YR4, IAWN issued its first ever potential asteroid impact notification to put the astronomical community on alert to collect as much information as possible on it to try to determine if it will impact. Thanks for watching. Request you to subscribe the channel.